Hi, and welcome to this course using prompt engineering to work with Git branches. My name is Janani Ravi, and I'll be your instructor for today. As you've studied in previous courses, Git allows you to track versions of your code and collaborate with your teammates for development. But what if you and your teammates are working on independent features with separate code commits for each? It will surely cause conflicts if you keep committing to the same line of development. And this is where branches come in. Branches are separate, independent lines of development for people working on different features. Once you've completed your work on a branch, you can merge all of your branches together to the main line of development. You'll start this course by creating separate feature branches on Git and pushing commits to those branches. You'll use prompt engineering to get the right commands to use for branching and working on branches. You'll also learn how you can stash changes to your project to work on them later if you have to leave your project halfway to, say, make an emergency bug fix. You'll save your changes by using the local repository stash. Next, you'll explore how to resolve divergence in your branches. Often, there might be contradictory code and commits in different branches, and these need to be resolved in some way. You'll learn that there are two ways to achieve this: merge and rebase. Merge is the simpler method where Git will try its best to combine the code from different branches. However, rebase is more complex where Git will attempt to replay the commit from all branches in the order that Git believes to be correct. You'll learn how to use both of these techniques to bring together code from different branches. In conclusion, this course will provide you with a basic foundation on how to use prompt engineering to learn a complex technology such as Git. At this point, you're quite comfortable working in Git and you understand how version control works. But what we've not yet looked at is how to work with branches in Git. And that's what we'll discuss here in this video. Now we know that Git makes it easy for multiple collaborators to work on the same project. Each one makes a copy of the remote repository on their local machine. They work on their local repositories. Now, let's say you're developing a feature that's going to take several weeks to complete. Now, you might want to commit to your local repository and even push to remote before the feature is entirely done. Now, if you were to do this on the main branch, you'll be cluttering the main branch with lot of extra code which is not really in its complete baked state. You don't want half baked code in the main branch. The main branch should be pristine clean, containing only code that has been fully tested and is ready for the next release. So, how do you accomplish this? Well, you work on your feature in a branch. Let's understand the regular workflow when we have just a single branch. We have our remote repository, which contains the source of truth, the original source code, which has been pushed out to remote from local repositories. When you have multiple teams on a project, they can clone this remote repo and work locally on their own copy. Let's imagine the scenario where this project is a fairly huge one and there are different teams working on different parts of the project. And Alice and Bob are team managers and they're implementing different features for different aspects of this project. Now, if Alice and Bob were working individually, it might be completely okay for them to just clone the remote repository and work independently on their local repositories. So, Alice has her local repository and Bob has his own. They keep making changes to the local repository as they're developing their features. And once they feel their features are in a fairly steady state, they can push all of their changes to the origin. So the changes for Alice as well as Bob will be both pushed out to the origin and will be available to other collaborators. Integrating all changes to the main branch in the remote repository works when there are just two or three collaborators in a repository. But what if Alice and Bob manage a dispersed team, multiple developers all working together on features? If you have, say, two or three separate teams where each team works on a separate project, it's far better to have a different branch for each team where each branch is focused on the development of a single feature. And all of the commits of these teams will be recorded on a branch. Now, we've seen that when you first set up a repository, there is a primary branch or a default branch that is set up for you. This branch used to be referred to as the master branch, but the modern, more inclusive term is to refer to as the main branch. You'll find that today people rarely refer to the master branch, they'll usually call it main or trunk. Now, because you've already worked with Git, you know that a branch is just a timeline of commits in your repository. You start off with an initial commit, that's an initial set of changes, and then you make more changes to the project over time, and each change is a commit, and each commit is another addition to your timeline. Now, let's say a number of changes have been made to the main branch already. So, your project is in a certain state. And at this point in time, the teams that Alice and Bob manage start their own projects. Each project, handled by either Alice or Bob, is a parallel line of development. So, they create their own independent branch for their team. Alice's team, say, works on the Alice branch, and Bob's team works on the Bob branch. Now, you'll have, of course, more meaningful names for your branches based on what feature it is they're developing or what bugs you're fixing. But for now, Alice and Bob branch will suffice. Now, Alice's team will only work on developing the feature on the Alice branch, and Bob's team will do likewise on the Bob branch. So, team members will clone their respective branches. They'll create a local repository from the branch that they're working on, either the Alice branch or the Bob branch. Every team member will make their changes to their local repositories, and once they're ready to have changes on the remote, they'll commit and push their changes to their own branches. So Alice's team will push to the Alice branch, and Bob's team will push to the Bob branch. Now, both Alice and Bob started off at the same commit on the main branch, but over time, their branches will diverge from main. Each branch will take on its own series of commits. Their teams are developing different features after all, but at some point, the teams will complete working on their features, and the feature will be ready to be integrated back to main. Let's say Alice's team finishes first, Alice's team will then merge their changes back to the main branch. They'll first need to ensure that if main has moved ahead and has additional changes, they'll need to integrate with those changes as well. And once Alice's team is done, maybe at some point Bob's team will finish working on their feature and they'll merge back to the main as well. At this point, the main branch for our project now has both features, both from Alice's team as well as Bob's team. Now, because both Alice's team and Bob's team are working on the same project, it's quite possible to have conflicts during the merge. Maybe Alice's team made some changes that directly contradicted Bob's team's changes. Maybe they're working on the exact same file and they've changed the exact same line, but each have changed it to something different. Alice has said brew tea for 10 minutes, Bob says brew tea for 5 minutes. Because Alice's team merged their changes into the main branch first, Alice did not face any problems. But when it comes time for Bob's team to merge their changes to the main branch, well, there's going to be a conflict. Do we brew tea for 10 minutes or 5? Well, we need to figure out which version of the file to accept. Now, there is no one way to deal with a merge conflict. You have to use your judgment to see what version of the file to accept during the merge process. Resolving merge conflicts might involve collaboration between team members to figure out the right version of the final file. You can also use conflict resolution tools in order to make the process easy. We've discussed that branches in Git are a fundamental concept that allow you to work on different lines of development within the same repository. Branches are separate copies of your project where you can make changes independently of each other without affecting the main project until you're ready to merge your branch features back to main. In this demo, we'll move beyond using the main branch, the default branch that we worked in so far. We'll create new branches for our features and we'll commit the changes that we made for the new features and bug fixes directly on to the feature branch that we have created. And then when we are ready, we'll merge those back into main. But before we get started with anything to do with branches, let's ask ChatGPT for some guidance. How do I see what branches I currently have in my repository? This is something that we need to know before we do anything. And it's pretty clear that we have to use the git branch command. It'll list out all of the branches and it'll mark one with an asterisk. That's the branch that you're currently on. Now that we know how to view the branches in our repository, let's see how we can create a new branch. I asked ChatGPT this question and it tells me, well, I can use the git branch command to create a new branch, except that I specify the name of the branch. Once we've created a new branch, we can list the branches that we have by running just the git branch command with no additional input arguments. And we can switch to working on the new branch using the git checkout command and specifying the branch that we want to switch to. And here is the single command that combines everything that we've seen so far. Git checkout dash B and the new branch name will create a new branch and switch to that branch so that we start working on that branch. Let's put everything that we learned here into action. I'm going to run git branch to see what branches we have available. We have just the one main branch, the default branch in our repository. Now, let's create a new branch so that we can prototype a new feature. I'm using the git branch command to create a new branch, and the name of the branch is power of prototype. So, I'm going to prototype the arithmetic function power of here in this new branch. Now, let's run git branch once again, and we now have two branches in our repository. There is the main branch that we are currently on, and then the new branch that we just created, power of prototype. We know how to switch to a new branch as well. I use the git checkout command and I specify the branch that I want to switch to, power of prototype. It seems like I've successfully switched over to that branch. Let me run the git branch command once again to see what branch I'm on currently. And it says I'm on the power of prototype branch. So I can start prototyping my power of arithmetic function. Now, this branch here contains all of the code that was in the main branch at the point of time where we actually created this branch. Just something that you should keep in mind as we start working here in this branch. Now, my question here is how do I make changes and commit my changes to my new branch? Let's see what ChatGPT has to say. The first thing to do is to ensure that we are on the new branch. We've already done that. Once we are on the new branch, all we have to do is start making changes to the files in our project exactly like we would if we were on main, and then add those changes so that they're in the staging area and then commit those changes to that branch. Well, this seems straightforward enough. Let's go ahead and start working on our feature in this new branch. At this point, our local repository and our remote repository are completely in sync and up to date. Let's run git status. We are working in the power of prototype branch and there is nothing to commit here. The working tree is clean. Let's take a look at the files that we have in our local directory, and here are the latest changes to our project. Our working directory is up to date with all changes made to this project. Now, earlier I'd created a prototype of the power of arithmetic function in this prototypes folder. And I'd mentioned you at that point in time that this is not a great practice. Really, we should be developing this prototype in a branch. And this is exactly what I'm going to do. I'm going to basically set up this prototype in this new branch that I have created. I'm going to copy over this powerof.py file and I'll call it powerofnumbers.py and it's going to be in my current working directory. This arithmetic function, powerof, is going to be a feature alongside the other features that we have to add, subtract, and multiply numbers. And it's going to be in the same directory. Let's run ls-l and you can see power of numbers now sits next to all of the other arithmetic functions. By copying over the file from the prototypes folder, what I've done here is created a new file in this project. Git status shows me a new untracked file, the power of numbers file. Let's take a look at the contents of this file. I open it up on Sublime Text and you can see that the function doesn't actually return a valid value. Let's make those changes. So if power of is successfully computed, we return the result. If there is an exception, we return none. And after we compute the power of numbers, I'll print out computed result to screen. Let's run git status once again. I should have the power of numbers file as untracked. There is absolutely no change to git status. The power of numbers file's contents have changed though. Let's quickly test that our new feature works as expected. I invoke power of numbers, pass in 2 and 3. 2 raised to the power 3 gives us 8. Things look good so far. Let's call power of numbers once again and pass in 5 and 5. 5 raised to the power of 5 gives us 3125. Again, great. I'll now invoke the code with no command line arguments. Let's see if the usage statement is printed out. The usage says Python power of pi, but I've changed the name of my file. So I'm going to change this to power of numbers.py. Now I've made all the changes I need to. Let me test this once again. Everything seems to be working as expected. At this point, I'm ready to commit the changes I have here in the feature branch to my local repository. I call git add dot to stage these changes for commit. Let's run git status and let's ensure that our one new file has indeed been staged. Notice that we are still on the power of prototype branch. The changes have been staged to this branch, not to main. And now when we run git commit, the changes will be committed to the power of prototype branch. Changes will not be committed to main. We are in a completely different line of development. I'll quickly run git status here to make sure that the working tree is clean. Yes, indeed it is. Let's run a git log to see whether our commit has been successfully saved. And you can see our latest commit here. The latest commit that we just did was to the power of prototype branch. And you can see that the head pointer points to this commit in the power of prototype branch. Notice where main is at. Main is one commit behind us, and our remote repository origin main is also one commit behind us. This is the point where we created a new branch and started working on our new feature in that new branch. Now we've committed the changes that we made to a branch to our local repository. But if you head over to GitHub and look at our remote repository, we have just one branch there. The branch that we just created, the power of prototype branch, well, it's not available here. Again, this should be no surprise to you because while we created and committed to that branch in our local repository, we haven't pushed the branch changes to GitHub to remote. All right, let's try and do exactly that. Let me run the git branch operation to make sure that we are in the right branch. We are still working on the power of prototype branch. Things are good here. Let me try and push this branch to origin. And I run git push -u origin main. I get this message that says branch main set up to track origin main. Everything is up to date. Well, it's not really up to date. I have something in my power of prototype branch. Let's really understand what this means by returning to our trusty ChatGPT assistant. First, let's explain what exactly it was that we tried to do. We tried to commit changes made in a branch using the git push -u origin main command. Now, I think I realize what the issue is, but I really want ChatGPT to confirm. The status said everything is up to date, but I do have changes in my branch. And this is where we've done things mechanically, and that's why they didn't work as expected. Git push origin main is used to push changes from the local main branch to the main branch in the remote repository. But our changes are in a different feature branch, power of prototype. So we need to check out the feature branch, make sure we commit our changes there. We've done that. But when we call git push, it should be git push -u origin and then the name of the feature branch. That's the command that you see here at the bottom. And let's do exactly this. Git push origin, that is our remote, and push from my power of prototype branch in my local repository. And this time around, you can see that our changes have been pushed to remote. The next thing we want to do is check whether this new branch is now present in our remote repository. And you can do this by running the git branch -r command. And here you can see clearly that our remote repository now has two branches, main and power of prototype. And here is another very useful way to visualize which commits are present on which branch using the git log and viewing the tags that are associated with the log output. The head pointer of our local repository points to the last commit on the power of prototype branch. That's where we completed the power of function. The remote power of prototype branch also points to this last commit. That's the origin / power of prototype tag. But origin main and the main of our local repository is one commit behind. And that's the commit where we merged with the remote repository. So you can see where exactly all the different branches are at. Let's verify that changes are as we expect by heading over to GitHub. Here on the main branch, notice that the latest commit is the merge of the main with our local repo and our push, but it does not contain the power of prototype changes. Let's go to our main repository page, arithmetic in Python, and notice that little yellow banner on top, power of prototype, had recent pushes 3 minutes ago. Another thing to observe, notice the link here, two branches, no longer just one branch. And if you click through, here are the two branches, main as well as power of prototype. One last thing to confirm that the power of prototype contains the changes that we expect. Here in the main page of our repository, I'm going to use this drop down to switch over to the power of prototype branch, and notice we have this additional file here, power of numbers. This is the additional bit of code that we checked in and pushed to the remote repository in the power of prototype branch. In our first branching demo, we created a new branch and then switched to that branch, made changes to our working directory, and then whatever changes we had made, we committed to the new branch. Here we'll follow a slightly different route to create and check in features into a new branch. We'll start by making our changes on the main branch, and when our feature is ready, only then will we switch over to the feature branch and commit our changes. Now, it's quite possible that you start by working out in your main branch. And I'm going to do this by checking out the main branch. This is how I'll switch to working to the main branch rather than the power of prototype that I'm on now. Now, you can also change to a different branch using the git switch command, provided that you're working on a recent version of Git. This command should be available for any version after Git 2.23. Now, when you switch over to the main branch, your working directory is updated with all of the files available at this latest commit of main. Let's first confirm we are indeed on the main branch. Git branch shows us that this is true. Now, if you were to run an ls-l in your working directory, you'll only find files that have been committed to and pushed to our main branch. Notice that the power of numbers file isn't in here. Now, here in the main branch, let's start working on our new feature. I want to add the arithmetic function to be able to divide one number by the other. I have the divide function defined on lines 3 through 14. Notice that this divide function returns a result or returns none. And then I invoke this divide function within main here on line 16 through 28. Working on the main branch, I've added this dividing numbers file to my current working directory. And you can see it in here with the ls-l command. Notice dividing numbers.py. Now we are on the main branch and we started working on a prototype for a new arithmetic function. You know that these arithmetic functions cannot be checked into main. That's not a best practice. Let's run a git status and you can see the new file that I've added to my current working directory. It's currently untracked by Git. It's pretty clear that we have to create a new branch, and whatever feature I'm working on, those changes I'll commit to the new branch and we'll only merge back to the main when we are absolutely ready. Actually, I had meant to start working on my new changes in a new branch, but I forgot to do so and started working in main. This happens to me. So let's ask ChatGPT what to do now. I meant to work on a different branch, but I started making changes in main. How do I fix this? What do I need to do to actually fix this? When I ask this question, ChatGPT suggests an option that's reasonable, but it involves working with a new command that I don't understand and I'm not familiar with. It asks me to stash my changes and then apply my changes. and then commit my changes. Now, this seems a little overwhelming to me at this point in time. I don't want to think about stash. So maybe I'll ask a follow up question. Do I need to stash my changes? Can't I just create a new branch and start working from there? And it turns out that this is something that you can do. If you're working on main and started making changes in main, but you meant to work on a new branch, you can simply create a new branch and start working from there. ChatGPT now seems quite confident that if you haven't committed your changes to main branch yet, you can safely switch to a new branch and continue your work there. And it gives me the steps for doing so. So remember, ChatGPT or Bard may not get things right at the first go. It may not get things right at all. They are great assistants. You can use them as a guide, but you cannot blindly follow what they say. You can see that they've been super helpful so far. They haven't led me astray, not much at least, but they can lead you astray. That's something you have to keep in mind as you're following instructions that ChatGPT generates. Now, here you can see instructions for creating a new branch and then switching over to the new branch in one go. This is the git checkout -b command that will create a branch and switch us over to that branch. So let's do that by going back to our local machine. I'm going to create a new branch called divide prototype where I'll check in my changes to add a new dividing numbers function. So we've now switched over to the new branch that we've just created. Run the git branch command and you'll see that we have three branches now: main, power of prototype, and divide prototype. And we are currently on the divide prototype branch. This new branch, divide prototype, was forked from the latest commit that we had on main. So at this point, at the time that this branch was created, it reflects exactly all of the commits that were made on main. And you can see that the changes that we had in our current working directory, well, our working directory has remained the same. We've just forked from the main branch. You can see the changes here as well. The dividing numbers file is currently untracked. I'm going to go ahead and add it to the staging area so that Git starts tracking this file using a git add. Now let's confirm that this is in the staging area by running git status. It is indeed on the branch divide prototype. Now when we run the git commit, all our changes will be committed to the divide prototype branch. So we added the divide functionality and committed changes to divide prototype. Notice the commit message says divide prototype and then the hash. That's because we committed to the divide prototype branch. Now let's run a git log and this will give us the log of commits on the divide prototype. Our head pointer points to the latest commit on divide prototype. We added the divide functionality, but origin main and the main branch is one commit behind. So we branched from main and added one additional commit to the divide prototype branch. We have the new branch in our local repository. Let's push the changes in this new branch to remote as well. Git push origin divide prototype will actually push changes from the divide prototype branch to the remote repository. We reference it as origin in our Git repo. Let's do a quick confirmation that this branch exists on GitHub. I hit refresh and you can see the messages here. We have a new message. Divide prototype had recent pushes just a minute ago. It's very helpful for us to know whether there have been changes on the new branch. Observe that we now have three branches, not two. And if you click through, you'll find the three branches: main, our default branch, divide prototype, and power of prototype. Let's click through to the divide prototype and you should be able to see the new files that we've added to this branch. There's that one new file, dividing numbers.py, and here is the code in that file. Now, if you switch to the main branch, this file should not be present in the main branch. Let me show you this. Select this drop down and select the main branch. Remember, this dividing numbers file is only present in the divide of prototype. And when you try to access this file in the main branch, you get a 404 page not found. Here's something that often happens with me when I'm working on any kind of software development project. I'll be working on a feature and this feature requires some time. So I iterate, improve the feature. Maybe this project lasts for a couple of weeks. Now, at the same time as I'm working on the project, emergency bug fixes come in from customers. And these bug fixes take priority over whatever feature development I'm doing. This means I have to stop work on whatever I'm doing, switch to making the bug fix, and then pick up from where I left off. Usually, I'll be working on a feature branch. If I can commit the changes I've made to the feature branch, then things are just fine. I'll just commit the changes, switch to the bug fix, and everything is just hunky dory. But what if my changes are in some kind of state where things don't build, nothing works? I don't really want to commit these changes to the feature branch. What do I do then? And this is where the git stash command is so very useful. We saw that ChatGPT recommended stashing our changes in order to move to a new branch and start working there. But at that point, I felt that was not the right thing. I was too overwhelmed. I didn't want to think about stashing. But now we are ready to understand how git stash works and how it allows us to temporarily stash changes while we work on an emergency fix. Now, let's say I'm working on a feature that is a long refactoring operation. I switch over to the main branch and I'm going to be making my changes here in the main branch. And my idea is that at some point, I'll switch to a feature branch and check in all of my refactoring changes. Now, here is the refactoring that I plan to do. I have three files here, adding numbers, subtracting numbers, and multiplying numbers. These are completed features checked into the main branch. I don't want each of these to have a main module which actually invokes the add, subtract, or multiply function. I'm going to move all of that into a separate file. For each of these Python files, I'm going to remove all of the code that has to do with parsing arguments and then invoking the right function to perform that computation. So I did that for adding numbers. I'm going to do the same for subtracting numbers. So all of the invocations of the different arithmetic operations will be from a single file. That's the end objective of this refactoring that I plan to do here in my project. So I'm going to go ahead and delete the invocation code here in multiplying numbers as well. Make sure you save all of the changes. I've modified the three existing files in our project. Let's quickly run a git status and see the status of this working directory. You can see the three files that have been modified. Now I definitely want to stage these for commit. So I'm going to go ahead and add these files to the staging area. I'll run git status to confirm that they are indeed in the staging area, and you can see that they are. In my head, I want these modifications to be part of the next commit that I make to a feature branch. Now I need to add a main.py file as well, which will actually invoke the right arithmetic function based on an input argument that the user has specified. On lines 2, 3, and 4, you can see that main.py imports the add, subtract, and multiply functions from the other Python modules. I've then set up a function map here, mapping the operand to the corresponding function to invoke. If the user specifies the plus operand, we'll invoke add, the minus operand, subtract, and the x or the multiplication operand, we'll invoke multiply. When the user invokes main.py, the user specifies three command line arguments: the two numbers on which the arithmetic operation has to be performed, and the operand specifying what arithmetic operation needs to be performed. These are then parsed. These command line arguments are parsed on lines 21 through 23. On line 25, we use the operand to look up the right function using the function map, and we invoke the function on line 27 and print out computed result. So this is my refactoring change. Now I'm very happy with this change. I look at git status and there is one untracked file here, that is main.py. I'm going to go ahead and add main.py to be in the staging area as well. This is going to be part of my next commit. After having made the refactoring change, the next step is to actually test this change. Let's quickly run through the test. The plus operand seems to work just fine. The minus operand also seems to be working fine. And the multiplication operand also works fine. Now, I'm in the middle of testing and figuring out whether I need to do anything else when an emergency bug fix comes in. My team member comes up to me and says, "Stop with your refactoring work. Here is this emergency fix that you have to make." But I have all of these changes that I'm not ready to commit to a feature branch yet. What do I do? Let's see if ChatGPT can help us. I'm still in the context of the larger conversation on Git, so I can simply continue my conversation. I need to make an emergency bug fix on the main branch, but I have all of these complex refactoring changes that I'm working on. Is there any way I can save these changes? And ChatGPT tells me, yes, there is indeed a way I can save these changes without committing them to the main branch or to any other branch. And this involves creating a temporary stash. And it gives you all of the commands to explain how you actually use this temporary stash. A stash is just a space away from your working area. Our working folder is kind of like our table. And then if you want to clear our table temporarily, we just move everything in the working directory over to some other table, our stash, perform our other jobs on the main table, and then bring the contents of the stash back to the table when we are ready to deal with them. You can see here that the command to stash your changes to a temporary location is just git stash. So, whatever changes I have on the current branch, I can run git stash, and those changes will be saved out to some temp location and I can access them later. In addition to creating a temporary stash, it gives me other options like creating a new branch, committing to that branch. Let's ignore all of those other options. Let's focus on the stash because that seems to fit what we want perfectly. But I have one additional question here. And for a little variety, I'm going to ask Bard this question. Your stash is not meant for just one set of changes. The idea is the stash works like a stack and you can stash multiple changes one on top of the other. Now, my question is, how do I remember what exactly a change is about? If there are multiple changes in my stash, just like we have commit messages, is it possible for me to add a description or a message to each stash? Well, let's ask Bart this. I'm planning to stash my changes to work on an emergency bug fix. Can I associate a message with my stash? ChatGPT's response did not say anything about a message, and I want to know whether it's possible. And to this more direct question, Bard has a clear answer. You need to call git stash save and specify a message associated with that stash. Well, this is very clear. I think I've understood how stashing works. Let's switch over and apply this. I'm on the main branch and I want to stash the refactoring changes that I'm working on in main to perform the emergency bug fix. I use git stash save and associate a message with my stash, refactoring to use a single main.py file. That's what the contents of the stash will include. When you call git stash with no additional parameters, no additional flags, this will only stash changes that are tracked by Git. That is, changes in your staging area and other modified files that Git knows about. It will not include untracked files that have not yet been added to Git's index using git add. Now, all of our files have been tracked, which is why all of the changes have been successfully stashed. You can run git status and you'll see that we have a clean working directory. An additional PyCache folder that was created, which is untracked, that has not been added to the stash. At this point, we have a clean working directory and we are ready to perform the emergency bug fix. Having stashed our changes on main, we are now ready to make an emergency bug fix, and that's in the Power of Prototype branch. Now, the branch that we're currently on is the main branch, and Git branch shows us this is exactly the case. We need to switch to the Power of Prototype branch. So I can run git checkout Power of Prototype or git switch Power of Prototype to move to the branch that I want to work in. If you remember, this Power of Prototype branch is where we are developing the power of arithmetic function. And you can see the power of numbers file is present here in this branch. If you remember, we had this prototype for the power of function in the prototypes subfolder. We had created this before we actually set up branches for our new features. Now I want to get rid of this power of.py file here under prototypes. I need to delete this altogether. This was the emergency bug fix. They didn't want extra code cluttering up this branch. Now I've removed this file from my local machine as well as from Git. And when you run git status, you can see that this file is in the deleted state. Now these are the changes I want to commit. I'm going to go ahead and call git commit. This will commit these changes I've made to my local repository. That means this powerof.py file will no longer be present in my local repo in the power of prototype branch. I want these changes pushed to the remote repo as well. Make sure you push to origin and you push from the power of prototype branch because that's the branch in which we are currently and in which we are making changes. Our remote is now up to date with the deletion of this file. Let's run git log and confirm that this is indeed the case. You can see that our head pointer and the origin power of prototype branch are at the latest commit here, where we've deleted that Python file under the prototypes folder. The power of prototype branch is now well ahead of main, 2 commits ahead of origin main and the main branch in our local repo as well. At this point, we are done with our emergency fix. Let's ask Git how we can get back to working on our refactoring code. I actually have no idea, now that I have a stash, how to get the changes back from the stash. I'm done with the emergency fix. How do I go back to working on my refactoring code? And ChatGPT has a ready answer. We first need to commit or stash our changes. We've already committed changes for our emergency bug fix, so we are all set there. We then need to switch to our feature branch, that's just the main branch where we were performing refactoring. And then we need to reapply our changes if stashed. Our changes are indeed stashed, we need to reapply them. And the right command to do that is to use git stash apply. So whatever changes we've stashed, this will simply apply those changes. If we don't need the stash anymore, we can then drop the stash by calling git stash drop. Or if you want to apply the stash and drop it at one go, you can use git stash pop. The pop operation will apply the changes in your stash to the current branch and delete the stash at the same time in one go. Now, this pop operation should give you a clue that the stash is actually a stack, a last in, last out structure. As you add more changes to the stash, it's added to the top of the stack, and the last change that you've added is what you'll retrieve first. Let's ask ChatGPT if there is a way we can see what's in the stash, all of the different changes. And ChatGPT says you should use the git stash list command. And you can also inspect a stash by using git stash show and specifying the ID of the stash. Here, n is the index of the stash that you want to inspect. In the stack that makes up the stash, every set of changes that you add to the stash is identified by an index. I'm now ready to go back to my refactoring code. Let's switch back to the main branch, and this time I use the git switch command. Now let's take a look at the contents of our stash, and we can do this by running git stash list. And this shows me there are exactly one set of changes in my stash. It's uniquely identified using stash at 0, where 0 is the index of this set of changes, and you can see the message associated with these changes as well. We can use the git stash show command to see what changes are there in the stash, and you get a succinct overview of the changes. We made changes to adding, multiplying, and subtracting numbers. We removed some code, and we added a bunch of code in main.py. If you want to view a particular set of changes in the stash, you use the identifier. Git stash show stash at 0 will show us the changes at index 0 in the stash. I'm on the main branch here. I'm ready to apply the changes in my stash to my main branch. Git stash apply will do the trick. And this will run a git status as well and show you what changes are now in your working directory. We have a new file main.py and 3 modified files that are not yet staged for commit. We'll need to restage these files. At this point, we have all our refactoring changes back in our working directory, and our main branch is up to date with origin main. We are ready to stage all of our changes to be committed. So I call git add star.py. I'm not going to commit these changes directly to the main branch. Instead, I'm going to commit them to a new branch called refactoring changes. I create and switch over to this new branch. The changes in my working directory are still available, and we'll confirm that with a git status. And these are the changes I'm going to commit to this new branch called refactoring changes. This is just a simple git commit call that we are all familiar with. Let's commit the changes to our local repo, and let's push this out to the remote repository as well. Remember to specify the refactoring changes branch on our local repo. That's what we want to push to remote. Our refactoring changes branch will now be available on the remote repository as well. Now the changes should be available on remote. We'll look at that in just a bit. we are still working on the new branch refactoring changes. Remember, we switched over to this branch and then committed changes. If you run git stash list, you'll find that our changes are still present in stash. Now we no longer need these changes to be in stash because we've applied and committed these changes. So if you remember from ChatGPT's instructions, we can call git stash drop to drop all of the changes in our stash. And we've done that successfully. Let's run git stash list again to confirm that our stash is empty. There's just one last thing to check before we complete this demo. Let's head over to our remote repository and refresh and make sure that refactoring changes have been successfully pushed to our remote repo. And you can see from the message here that they have. Let's click through to the refactoring changes and make sure that the right files are in here. Notice that this branch is one commit ahead of main. That makes sense. We have the refactoring changes in there. And notice that we have the main.py file here. We now have our refactoring changes successfully committed and pushed to the remote repo in a different branch. At this point in our project, we have our main branch and then 3 different prototype branches. At some point, the features that we've been prototyping, we'll need to merge back into the main branch. But before we do that, let's look at this really cool visualization that I found online that allows us to visualize how branches work in Git and how branches support parallel development. I'm here in the URL gitschool.github.io/visualizing Git. Here we'll see how development along different branches can occur in parallel and how each branch can evolve independently. Notice right now I have just a single branch, the default main branch, and the head of my local repository is at the latest commit in the main branch. Now, the actions that we want to perform in any branch can be typed into this little input text box at the bottom left of the screen. Let's say we have some changes in our workspace that we want to commit to the main branch. Notice that a commit has been added to the branch and the head pointer moves ahead. Every commit that you make to the main branch will add to the commit history, will change the files and folders in your workspace, and your head pointer will move ahead by one. Remember, the head at this point points to the latest commit. So far, our development has been very linear, all in the main branch, but let's say we decide to move to a new branch to perform a bug fix. So I git checkout -b bug fix 123, which will create a new branch and move my head pointer to the new branch. At this point, the state of the branch is exactly the same as the state of main. You can see that master or main and bugfix123 and head all three point to the same commit. We've created a new branch, but let's switch back to the main branch and continue our development in the main branch. Git checkout master will check out the main branch. Now, once that's done, let's perform some more commit operations, and this will cause the main branch to move ahead of bug fix. So the main branch essentially has new commits that bug fix does not have. Now let's check out our bug fix branch, bugfix123, and continue our development and fix that bug that we were looking at. The git checkout operation here will move our head pointer back to the commit where bugfix was actually forked. So it moves back one commit. Now let's continue making the bug fix, and the git commits that I perform right now will be on the bugfix branch. Notice now bugfix is developing independently of main. I perform a few commits here on bugfix. You can see the head pointer and the bugfix branch moves forward, but the changes in main are now not in bugfix and vice versa. Now, at some point, you might want to switch back to the main branch and continue your work there. So git checkout master will take you back to the main branch. Notice the head pointer has moved. Now, if you continue committing changes to the main branch, once again, main moves ahead independently of bugfix. There was a point at which they forked, and now development continues in parallel. Now, let's create one more branch. Maybe another bug fix has come in, and I call this branch bugfix456. Git checkout -b will create the branch and move my head pointer to that branch. So I'm currently working on the branch bugfix456. let's make a few commits to this bug fix branch, git commit. Now, bug fix moves ahead of main. It forked from main at some point, but now it has moved ahead of main by one commit, and another commit operation will move bug fix 456 ahead of main by two commits. I'll now go back to our main branch, git checkout master, and let's perform some additional operations here in the main branch. I perform a few git commits, and now main is developing and moving forward independently of both bug fix branches. Development on main now follows its own path, and each bug fix branch has its own line of development. At some point, when you're finally deploying to production, you'll have to merge all of these independent lines of development onto the main branch so that the main branch is what is deployed. And as you check out each branch, notice the head pointer moves to the last commit in that branch. Let me run a git checkout once again and go to bugfix 456, and my head pointer now moves to the last commit of bugfix 456. Hopefully, this very cool visualization has solidified your understanding of how we can create different branches for independent lines of development and how the head pointer moves along these different branches as you check out individual branches to perform your work. Back to our project, at this point we have three different branches in addition to the main branch in our project. Let's see what those branches are. I'm going to run a git branch, and you can see that we're currently on refactoring changes, but we have a total of four branches. The divide prototype branch and the power of prototype branch contain new features that we'll have to integrate with main. And then refactoring changes, of course, contain some refactoring work that we've done. My objective here is to merge all of the changes that I have in my feature branch, the divide prototype branch, to the main branch. Let's say I've completed testing and I'm ready to make all the changes available on main. Let's check out the divide prototype branch and let's take a look at what the working directory looks like. You can see here we have this additional file dividing numbers.py. This is functionality that's not present in main. Let's get ChatGPT's guidance for how we accomplish this. I have changes on a branch and I want to merge those changes with the main branch in Git. What command do I use? And ChatGPT very helpfully gives you a step by step list of commands that you have to run. The first thing we have to do is ensure that we are in the main branch and then run the git merge command. Git merge will merge all of the changes that we have in the feature branch to main. Next, we check to see whether there are any conflicts. If there are any conflicts between the changes that we've made on our feature branch and the changes that exist on main, we'll have to resolve those manually. Now, we won't have any conflicts for this very first merge that we're about to do, but if you do have conflicts, you resolve them. Then you run git merge continue. If you want to abort the merge, you run git merge abort. Now, if the merge runs through without any conflicts, you don't have to explicitly commit the changes made by the merge. But sometimes, if you're manually resolving conflicts, you might have to explicitly commit the merge and then, of course, push out the changes to remote. I'll now switch back to our project repository. And the first thing we need to do is ensure we are on the main branch. So I run git checkout main. Now, let's look at the commits that are in the main branch and make sure that our head pointer is up to date and completely synced up with the remote repository. You might want to run a git fetch or a git pull if you're not completely synced up on your main branch with the remote repository. You want to make sure all changes in the remote are also present in your local repo. Now I know that I'm up to date with the remote repo and I can see it here in the commit log as well. Head main and origin / main both point to the same commit. Now, having satisfied myself, I'm ready to merge changes from the divide prototype branch to my main branch and I run a git merge command. The merge operation will integrate changes present in our branch with the main branch. And this time, the merge runs through successfully. There are absolutely no conflicts. That's because the divide prototype branch is only one commit ahead of main, and there were not very many changes to merge. It's only the dividing numbers change that was added. Let's confirm that our workspace has this file. I'll run an ls-l and you should see dividing numbers in here. Because the merge was performed automatically, we do not need to explicitly commit our changes. And I'll prove this to you by running git status. Git status shows you that there are no new changes in your current working directory. There are no uncommitted changes. The merge operation that we just performed automatically committed all changes from the divide prototype branch back into our main branch in the local repository. And git status gives us a very helpful message here. Your branch is ahead of origin main by one commit. So our local repository is now ahead of main because we have this new merge commit. Let's run git log and take a look at the last commit here in our local repo. And really, the output here from the git log command is very descriptive. Notice the latest commit here on the local main branch. Our head points to the latest commit, which is the same as the latest commit in origin divide prototype as well as the local divide prototype. And here you can clearly see that origin main is one behind us, one commit behind. And we can confirm this by heading over to the remote repository. Here I am in the main branch of my remote repository, and you can refresh and look at the contents. Notice that the dividing numbers file that is now in my local repo is not available here in the remote repo. Now, this feature is present in the divide prototype branch. So, if you switch over to that branch, you can clearly see that this branch in the remote repository is one commit ahead of main. And this one commit, you can click through to that link and see what that commit is. And that commit is when we added divide functionality. We've merged this change into our local repository. Now it's up to us to actually push this change to the remote repository, and we'll do this via a git push command. Because there are no merge conflicts and we are up to date with the changes in the remote repository, this git push will go through successfully. There are no conflicts we need to resolve. Everything is smooth sailing. Let's take a look at our git log and notice now all of the different tags here on the latest commit. The latest commit in the main branch of our local repo, well, it's the same latest commit that's in the main branch of the remote repository, and it's the same commit as the latest commit in the divide prototype branch. And if you now head over to your remote repository and hit refresh, you should find that your main branch contains all of the changes that existed in the divide prototype branch. We are currently on the main branch and you can see the dividing numbers.py file in here. If you remember a few minutes ago when we looked at the divide prototype branch, it was one commit ahead of main. But now if you look at the divide prototype branch, you can see that this branch is up to date with main. Now we have other feature branches here as well. For example, we have another prototype branch, the power of prototype. Now, what's up with that branch? We knew that it was a few commits ahead of main because we'd added the power of prototype in there, but now it's also one commit behind main. Let's click through and see what that one commit is, and that is the divide functionality that we've just added to main. Main has now moved ahead, and power of prototype, though it has the prototype feature changes, it's now one commit behind main as well. Now that we've integrated the changes in the divide prototype branch with main, let's ask ChatGPT whether we should actually delete the divide prototype branch. And very unsurprisingly, it turns out there are pros and cons of doing so. The reason to delete feature branches include these four. It keeps our repository clean, it's more secure, we don't have unnecessary code lying around, and it's overall less maintenance. But the reason to keep feature branches, they're also compelling. You'll need them for bug fixes and updates, and it's easier for collaboration and it serves as a backup. In this case, let's say we are confident that we don't need the branch anymore. Let's ask ChatGPT for what commands we can use to actually delete this branch. Now there is safe deletion, git branch dash d, that is the lowercase d, that will delete the branch only after ensuring that all of the changes from the branch have been merged into main. There's also unsafe deletion, git branch uppercase d. This will basically not check to see whether the branch changes have been merged into main. It'll go ahead and delete that branch. And once you delete that branch, you'll need to sync that deletion to your remote repository as well. And this is done by running the command git push origin dash dash d and the name of the branch. Now that we know what commands to use, let's actually delete the divide prototype branch. First, ensure that you're on the main branch. You should not be on the branch that you're trying to delete. Git checkout main shows me that I'm already on main. I'll quickly run the git branch operation so we can see what branches are currently available and the divide prototype branch is in there. Let's perform safe deletion. We've merged all of the changes from divide prototype onto the main branch. Git branch dash d lowercase d divide prototype. And this branch will now be deleted. It's no longer available in our local repository. And you can confirm this by running the git branch command. Notice that the divide prototype does not exist anymore. The divide prototype has been deleted in our local repository, but if you head over to our remote repository, you'll see that the divide prototype branch is still there. I've refreshed here, and if you click on this drop down, you'll find the divide prototype branch, and you can actually navigate and see all of the content that was part of this branch. There is one last step that we have to perform. We have to ensure that we push the deletion of this branch to our remote repository as well. Git push origin dash dash delete and the name of the branch, divide prototype. This will push the deletion of the branch on our local repo to the remote repository. And now when we head over to GitHub, and here I am in the divide prototype branch, I hit refresh and I get a 404. The branch no longer exists. You can see that the URL here points to the non-existent divide prototype branch. Now let's go back to our arithmetic in Python repository. And if you look at the drop down here for branches, you'll find that the divide prototype is not listed. Also note that this link says 3 branches and not 4 branches. And if you click through, you can see refactoring changes, power of prototype and main, but no divide prototype. Our next objective is to merge the new features that we have in the power of prototype branch back with the main branch. That feature is now ready for testing and then production. Now we know that since we created the power of prototype branch, main has actually moved ahead by 1 commit. And if you look at the git log, this commit is the divide functionality that we just added to main. Let's confirm that we are in the main branch, and yes, indeed we are. Starting from the current point in time here in main, I'm going to create a new branch and check in a new feature to that branch. And this new feature is going to be the modulo arithmetic function. Here is the code for finding the modulo of one number with respect to another. The modulo operation basically divides one number by the other, and the remainder is referred to as the modulus. The code here is self-explanatory. I won't go into the details. I've added this modulo numbers file to my local directory, and when I run git status, you can see the change there. Modulo numbers.py is untracked at this point in time. Let me just test that modulo numbers works as we would expect. 7 modulo 3, that is the remainder when 7 divided by 3 is 1. So modulo clearly functions quite fine. 12 modulo 7, that is 12 divided by 7, the remainder is 5. Things look good. Let's run git status once again. It's still an untracked file. Now I'm going to check in this modulo feature to a brand new branch. Let me go ahead and add modulo numbers.py to the staging area first, and I do that with a git add command. And once that's done, I'll create and switch to a new branch, and this branch will be called modulo prototype. I use the git checkout -b command. Once we are on this new branch, I'm going to commit the changes for this modulo feature using git commit. Git commit -m, adding modulo functionality, and this functionality is now present in a new branch, modulo prototype. And if you run a git log, you can see that modulo prototype is now ahead of main and origin main by 1 commit. Let's push this new branch to the remote repository. Git push origin modulo prototype will push the changes we have in our new branch to remote, and you can actually head over to GitHub and ensure that these changes are present here in remote. You can see that modulo prototype had recent pushes less than a minute ago. At this point, we've successfully created a new branch with a new feature, but really, this was just some preliminary work and some preliminary setup that I did. What I'm really interested in is merging the changes in the power of prototype branch back to the main branch. Let's understand the current state of affairs here in this power of prototype branch. This particular branch is two commits ahead of main. Let's see what those commits are. You can see these commits have to do with completed the power of function and then deleting the power of py file under prototypes. But we also know that main has moved ahead by a few commits. This particular power of prototype branch is also one commit behind main. Let's see what that commit is. And this is the new divide functionality that we merged from the divide prototype branch back to main. So now we have to somehow reconcile all these different commits and merge the changes in power of prototype back to the main branch. Now you might think to yourself, well, power of prototype is behind main, so let me have it sync up with the changes on the main branch. And you might go to your local machine, check out the power of prototype branch. So you're working in power of prototype, and then maybe you'll perform a git pull operation, git pull origin main. This seems like a reasonable thing to do, but you'll immediately encounter an error. Observe the fatal error here. Need to specify how to reconcile divergent branches. Let's figure out from ChatGPT what this error means. Essentially, what you thought you were doing was pulling and merging changes from the main branch to the feature branch. But we got this error. What does this error mean? And thankfully, ChatGPT gives me a very clear explanation. This occurs when Git encounters a situation when the current branch, our feature branch, and the branch that we are trying to pull, that is our main branch, they've both moved forward independently. Git indicates to us that you need to reconcile these divergent branches, but there are two possible ways of reconciling these branches: the merge strategy and the rebase strategy, and Git wants to know which strategy to use. The first option is the merge strategy, where on the feature branch we run the command git merge main. This will integrate all of the changes from the main branch into our feature branch, and if there are any merge conflicts, we'll have to resolve them. The second option is to rebase our feature branch changes onto the main branch. And this is a slightly different operation. This will essentially replay all of the changes in your feature branch on top of the changes in the main branch. When we perform a git pull operation, we need to specify which strategy we want to use to integrate changes from main and feature branches. If you remember, we've run into this problem before when we were trying to integrate changes made by a collaborator with our local changes. This is essentially the same thing. So we have two options: merging a branch and rebasing a branch. Let's see what the difference is. I've forgotten what the differences are. Let's quickly refresh our memory. The merge strategy integrates changes from the two branches using something known as a merge commit. Merge commits are generally non destructive in nature, so the original commits in both branches are kept intact. Merge commits are also simpler, and merge commits also have fewer conflicts. If you want to integrate changes in your branches using rebasing, your commit history will be rewritten. The commit history will be cleaner, but the original commits may not show up as they did before. So you have a clean history, you don't have a merge commit, you'll simply replay changes from one branch on top of the other, but you might encounter more conflicts. And this actually convinced me. I don't want to deal with conflicts at this point in time. Let's try and perform a merging operation. You can see that a merge commit is preferred if you want a clean record of feature integrations, and rebasing is preferred when you want a cleaner commit history. This is where we left things off at the end of the previous video. We were trying to integrate the new changes that are present in main with our power of prototype branch. We thought once we integrate these changes, we can then integrate the changes we have in the power of prototype back to main. And we decided to go with the merge strategy. We are going to merge the main branch into our feature branch. This requires us to check out the feature branch and then call git merge main. So let's switch to our local machine and do that. First, let's see what branch we are on. I'm going to run the git branch command here. And you can see that we are in the power of prototype branch. So we don't need to switch branches. Now let's merge changes from the main branch to the power of prototype branch. And I do this by calling git merge main. This will create a merge commit, and if there are conflicts, we'll have to resolve the conflicts now. There happen to be no conflicts. Here is the Vim editor. I switch to insert mode by clicking on I, and then I specify a merge commit message. I hit escape to go back to the normal mode, and then colon WQ will save the changes I made in this editor and quit the editor. And at this point, all of the changes that were in the main branch have been successfully merged into our feature branch. Let's take a look at the git log and you'll be able to see the latest merge commit here. And let's try and kind of parse and understand what's going on. The latest commit here in our power of prototype branch, which is where our head is pointing to, is the merging of all of the changes from the main branch into our feature branch. The next commit after that, origin forward slash power of prototype, that's the last commit in the power of prototype branch in the remote repository. The main branch is still behind us. Origin forward slash main and our local main branch is two commits behind. We are at adding divide functionality. That's the last commit in that branch. At this point, all of the features from the main branch are available here in this power of prototype branch. ls-l shows you that dividing numbers is in here. Also, since there were no conflicts, the merge operation set up a merge commit, and git status shows us that there are no changes here in our working directory. Before we go any further, I'm going to bring the power of prototype branch in the remote repository up to date with all of the changes here we have in my local repo. Git push origin power of prototype will push all my local changes here in this branch to the remote repository. Let's head over to our GitHub repo and let's switch to the power of prototype branch and see what the changes look like. You can see that this branch is now 3 commits ahead of main. It's no longer behind main because we merged all changes from main into this branch. The 3 commits that it's ahead of main include the power of feature that we added and the merge that we just performed when we merged changes on the main into power of prototype. The next step for us is to integrate the changes that we have in the power of prototype branch back to the main branch. So I go to ChatGPT and I give it a clear explanation. My feature branch is now up to date with main. And now I want to apply the changes in my feature branch to the main branch. How do I do this? And ChatGPT had a very clear answer for me. There were 2 options. Here is option 1. Here is where we merge our feature branch into main. So we have to be on the main branch, call the git merge command, resolve conflicts if any, and then commit the merge if needed. And of course, then we can push all changes to the remote repository using git push. The second option is to rebase our feature branch into main. Now, I won't actually consider the rebase option right now. We'll look at that in the next demo. So let's ignore the rebasing and let's merge our feature branch into the main branch. That requires us to first be on the main branch. So make sure you git checkout into the main branch. Remember, the main branch is behind our feature branch. So if you run a git log, you can see main only has the divide functionality. It doesn't have all of the commits that the power of prototype branch has. I'll run an ls-l here to confirm that the power of numbers.py file is not present here in my working directory, and it's not. Let's perform the merge operation. I do a git merge power of prototype to merge changes from the power of prototype branch into my main branch. There were no conflicts to resolve. The merge was performed automatically, and now the main branch is up to date with whatever changes were present in the power of prototype. You can see here we have the power of numbers.py file. The main branch on our local repository is fully integrated with the power of prototype branch, but it's ahead of origin main by 3 commits. And this is something that you can confirm by running the git log command. The latest commit shows you that the main branch in our local repository is fully caught up with the changes in the power of prototype branch, but origin main is behind us, a fully three commits behind us. Well, this is easily fixed with a git push operation. This command will push all of the changes that we have in our local repository to the main branch of our remote repository. And at this point, our main branch in the remote repo is up to date with our local changes. Notice the power of numbers.py file is available here on main. Also, we fully integrated all of the changes in the power of prototype branch to our main branch. You can see that the power of prototype branch is up to date with main. No commits ahead, no commits behind. Now we have yet another feature branch and we haven't integrated the changes from that feature branch onto main. This is the modulo prototype branch. You can see from the dropdown, this is the branch that I have selected in the remote repository. You can see that this branch is one commit ahead and three commits behind main. Let's take a look at the commit where this branch is ahead of main. And you can see this commit is for the modulo functionality that we added here in this branch. Now I want you to look closely at the hash associated with this commit, AE0F9B6. Keep this in mind. I'll bring this up again a little later in this demo. This is actually significant. In addition, this modulo prototype branch is also three commits behind main. Let's see what these three commits are. And these are all the recent merges that we just performed. We merged the power of prototype into the main branch. Now, our main objective is to get the changes we have in the modulo branch onto the main branch. But first, we have to integrate the changes that we have in the main branch with the modulo branch, and only then can we get the modulo feature onto the main branch. Now, if you remember, we had faced the same dilemma before. The main branch and the modulo branch have now diverged, and we faced this problem before. And ChatGPT had indicated there were two options to deal with this problem. The first option was to merge the main branch into our feature branch. The second option was to rebase our feature branch onto the main branch. Rebasing involves replaying the commits of the feature branch onto the main branch. And we then asked ChatGPT the difference between merging and rebasing, and this is what it had told us. It had said, merge preserves commit history across branches, it's non destructive. Rebase actually rewrites the commit history to give you a cleaner history and may result in more conflicts. Since we already know how to merge from main to a feature branch and then from the feature branch back to main, that's what we did in the previous demo. Let's now use Rebase. First, I'm going to check out the main branch and make sure it's up to date with the remote repository. And I do this by running a git pull origin main. This ensures that what I have here in my local repository is up to date with the remote repo. Now that we know this is indeed the case, let's switch over to our modulo prototype branch. Git checkout will take us to that branch. I'll now run a git fetch command. Git fetch origin main will bring the changes from main down to our branch, but it will not actually perform any integration. Here I've just fetched the changes and now I'm ready to perform a rebase. Now, before performing the rebase, I'm going to confirm that I'm indeed in the modulo prototype branch, and that is indeed my current branch. And now I'll run the rebase operation. Git rebase main takes all of the changes that were committed on the current branch since it diverged from the main branch and replace those commits on top of main. This effectively moves the entire current branch to begin on the tip of the main branch, giving the appearance of a linear commit history. We've run git rebase main while on the feature branch, and it's the feature branch that has been updated. This is important to remember. And the way it has been updated is the latest commit at the tip of the main was taken, and whatever changes we had in the feature branch was replayed over the last commit on main. And we'll actually see evidence of this when we run git log. Notice that all of the commits that we had in main are now part of this branch. The divide functionality that was already there, then deleting the power of prototype, then merging all of the changes in the power of prototype and the main branch, And then finally, the commit in this branch adding modulo functionality has been replayed on top of the mains changes. Now, the fact that this branch's commit adding modulo functionality was replayed means that it has an entirely new commit hash. The hash that you see here that starts with 3F8A8C4, this is not the same commit hash that existed previously for this commit. Now, let me take you back in time to earlier in this video where I'd asked you to pay close attention to the commit hash for adding modulo functionality here in the modulo prototype branch. Notice the commit hash starts with AE0F9B6, but now the commit hash for that commit is different. It starts with 3F8A8C4. This is an entirely new commit that was replayed at the tip of the main branch. And this is what Rebase does to maintain a linear commit history. Keep this change in commit ID in mind as we perform the next set of actions. Now that I feel I have all of the changes from main here in my modulo prototype branch, I want to push the changes in my local modulo prototype branch to the remote repository. And I try a git push origin modulo prototype, and this results in an error. And this error is because of the rebase operation that we had performed. Since we've rebased our modulo prototype branch, which changes from the main branch, our local modulo prototype branch has diverged from the remote modulo prototype branch. You'll find that the git pull operation will also not work. If you try to git pull whatever is there in the remote branch, you'll try to pull it down to your local branch, this will also not work. We've seen this error before. You have divergent branches and you need to specify whether you want to rebase or merge your changes. Since we are in the process of understanding how rebase works, I'm going to go with rebasing the changes from the remote branch into my local branch. Now I'm going to set this property git config pull.rebase to true. This means every git pull command I make will be a rebase operation and not a merge operation. I would really not recommend that you do this unless you and your teammates have agreed that each time you're integrating changes from a remote repository to a local one or between branches, you always want to use Rebase. Because we're learning how Rebase works, I've set this property and now I'm going to run git pull origin modulo prototype. This will first fetch the changes from the modulo prototype branch on the remote repository, but it will not update our local branch yet. And then, since our pull rebase was set to true, rather than merging the changes that were fetched from the remote modulo prototype branch onto our current local branch, Git will actually rebase our current branch onto the fetched version of the modulo prototype. You can see a commit 3F8A8C4, the latest commit in our local modulo prototype branch. That commit was skipped since it has already been applied to our branch. And essentially, the rebase will rewrite the commit history of our local modulo prototype. And now, when you look at git log, you can see the commit history has been entirely rewritten. Whatever changes existed in our local branch since it diverged from the remote branch, those have been replayed on top of the remote branch's last commit. The remote branch was at the commit which has been tagged origin/modulo prototype, and the changes that we merged from main in our local branch have been replayed on top of this. Those are the two commits for completed the power of function and deleting the power of prototype. You can see that Rebase makes our branch history very, very confusing, though we have a linear sequence of commits. So really, you have to use it carefully. But now that we have pulled from our remote branch, we should be able to push back all our local changes to the remote branch so that our local and remote modulo prototype branches are in sync. At this point, we've successfully got all of the recent changes from main into our modulo prototype branch, and our local and remote modulo prototype branches are in sync. They're fully up to date. And now we are ready to integrate changes from the modulo prototype branch back to the main branch. And rather than using git commands for this, we'll do this on GitHub via a pull request. Here I am in the modulo prototype branch on GitHub. At this point in the remote branch, all of the changes from main have been integrated into the modulo prototype branch using a rebasing operation. And if you look at the commit history, you'll find that it's a linear commit history with no merge commits, but the commit history is harder to follow because each time we perform a rebase operation, it replaces commits from one branch on another. Really, I would only recommend that you use Rebase if you know exactly what you're doing. Let's head back to our main repository content. And here in main, you can see an option here to compare and create a pull request. A pull request is a mechanism made available on these remote hosting services for repositories. A pull request is also referred to as a PR. It's basically a way for developers to request that changes that they've made in a branch, typically in a feature branch or a fork, be reviewed and then merged into another branch, usually the main branch. We'll now create a pull request and request a merge for all of the changes in the modulo prototype branch to be merged into the main branch. Let's specify a little comment to indicate this is the case. I now want to integrate all changes from modulo prototype to main. And I click on this button that says create pull request. In an organization, this pull request will be sent to somebody who will actually review my code, make sure all of the changes look okay. And once the changes look okay, the reviewer can then integrate the changes that I've proposed into the main branch. You can see this little note here saying this branch has no conflicts with the base branch. The integration can be done without you having to resolve any conflicts. There are different choices here for you to figure out how you want to integrate changes from modulo prototype to main. You can create a merge commit, you can squash and merge. So all of the additional commits will be a single commit on main, or you can rebase and merge. Let's just go with a regular merge request. We'll create a merge commit on the main branch. Click on merge pull request and then go ahead and confirm the merge. And once this is done, changes from our modulo prototype branch will now be on main. And now if you go to look at the contents of the main branch, you'll find that the modulo functionality is here as well. Notice the modulo numbers.py file. At this point, all of the different features that we've been developing on different branches are now integrated into the main branch. Now, there is one last branch that we have, the refactoring changes branch that I haven't merged into main. Now, I've left that for you as an exercise. That's a more complex merge, but now you know how to perform merging and rebasing. Let's see if with Bard or ChatGPT's help, you can integrate the changes that we have in refactoring changes and bring them all to the main branch. That's an exercise you can do on your own. Now that you have the basics of working with Git under your belt, before we call it a day on all of the demos of this course, let's look at one last command in Git. Let's say you've switched machines and you're setting up your new machine and you want all of your remote repositories to be available on your new machine. Or let's say you're a collaborator on a repository that's managed by your team and you need to get the contents of that repository on your local machine. How will you do this? Well, let's ask ChatGPT. I'm going to be setting up a new working directory. That's when you have a new machine, or maybe you deleted your old working directory, and I need to get the contents of my Git repo. How do I do this? And ChatGPT is pretty specific about its answer. You need to use the git clone command. Git clone is one of the most useful commands in Git. This is what allows you to clone an entire repository hosted on a remote hosting service and get a local copy on your machine where you can develop and prototype your code. We first have to go to the location where we want to set up our working directory, so a folder on our local machine, and then we clone the Git repository by running the git clone command. So we'll run git clone followed by the URL to our repository. Let's put this into action and clone our repository into a new working directory on our machine. This is the arithmetic in Python repository, the repository I've been working on so far. I'm going to go back to my home directory and create a new folder called projects. I'll now cd into this folder Here is where I want my arithmetic in Python projects. I want to create a new local repository and clone from the remote repository to get all of the contents I have there. Head over to GitHub and here in the main branch, click on the code dropdown. And this is where you'll find the HTTPS URL to your repository. Copy this HTTPS URL over and then use that with the git clone command. Git clone and the URL path to your repository and basically wait for the cloning process to complete. Git clone will copy the entire remote repository onto your local machine. And now, if you were to run an ls-l command here, you'll find a folder called arithmetic in Python. This folder did not exist before. We had just created the projects directory. We hadn't created any subfolders within that. This is the clone of our remote repo. You can cd into this folder, and if you were to run an ls-l, well, this is your working directory. The entire contents of the remote repository is now available in your local machine. You've now reached the end of this course using prompt engineering to work with Git branches. And you've also come to the end of this learning path on Git. As we had studied in previous courses, Git allows you to track versions of your code and collaborate with your teammates for development. But what if you and your teammates are working on independent features with separate code commits for each? Surely it'll cause conflicts if you keep committing to the same line of development. Well, not if you use branches correctly. Branches in Git are separate, independent lines of development for people working on different features. Once you've finished your work on your branch, you can merge all of your branches together. We started this course by creating separate feature branches on Git and pushing commits to those branches. We also explored how to develop your code on the main branch, switch branches, and then ultimately commit to a feature branch. We also learned about stashing. If you have to stop work on your project halfway, say in order to make an emergency bug fix, you can save your changes by stashing them in your local repo. A stash is effectively a last in, first out data structure that allows you to store in progress code that you're not ready to commit to your local repository. Next, we explored how to resolve divergence between branches. Often, different branches contain contradictory code and commits. This situation has to be resolved in some way. As we learned, there are two ways to do this using merge or using rebase. Of these, merge is the simpler way where Git will try its best to combine the code from different branches and the divergences may need to be manually resolved if there are conflicts. Rebase is more complex. Git will attempt to replay the commits from all branches in the order that Git believes to be correct, rewriting the commit history along the way. We tried out both the merge and rebase methods and confirmed that the branch commits are combined properly. In conclusion, this course has provided us with a basic foundation of how to use prompt engineering to learn a complex technology such as Git, enabling us to move on to prompt engineering for learning Python. Coming up ahead. That's it from me here today. Thank you for listening.